Quantum computers are a type of computer that use the principles of quantum mechanics to perform computations. Unlike classical computers, which use bits, either 0 or 1, to represent information, quantum computers use quantum bits or qubits. Qubits can be in a state of 0 or 1, or both at the same time, a property known as superposition. This allows quantum computers to perform certain computations much faster than classical computers, such as factoring large numbers and searching large databases. Quantum computers are still in their early stages of development, but have the potential to revolutionize computing and solve problems that are currently considered intractable.
Quantum computing is important for several reasons. Speed. Quantum computers have the potential to perform certain calculations much faster than classical computers, especially for problems that involve large amounts of data or complex calculations. This could lead to breakthroughs in fields such as cryptography, drug discovery, and artificial intelligence. Security. Quantum computers can also be used to create new, more secure methods of communication and encryption. They can break many of the encryption techniques used today, but they can also be used to create new encryption methods that are virtually unbreakable. Scientific discovery. Quantum computers can be used to simulate complex physical and chemical systems that are difficult or impossible to simulate on classical computers. This could lead to new insights in fields such as materials science, biology, and chemistry. Innovation. Quantum computing is a relatively new field, and there is still much to be discovered and invented.
Quantum computers work by harnessing the principles of quantum mechanics, which are fundamentally different from classical mechanics. In classical computing, bits are used to represent information and perform operations. In quantum computing, qubits are used instead of bits. Qubits have the property of superposition, which means they can exist in multiple states at once. This is different from classical bits, which can only exist in one state, either 0 or 1, at a time. The ability of qubits to exist in multiple states simultaneously allows quantum computers to perform certain operations much faster than classical computers. Quantum computers use quantum gates to manipulate qubits and perform operations. There are many types of quantum gates, but some of the most common are the Hadamard gate, which puts a qubit into superposition, and the CNOT gate, which performs a controlled NOT operation on two qubits.
One way to understand the basic principles of quantum computing is through a video game analogy. Imagine you are playing a video game where you have to navigate a maze with multiple paths. In a classical computer, you would have to explore each path one by one until you find the exit. However, in a quantum computer, you can explore all possible paths at once, thanks to the property of superposition. Now imagine that you come across a locked door in the maze, and you need to find the key to open it. In a classical computer, you would have to try each key one by one until you find the right one. However, in a quantum computer, you can use a quantum algorithm called Grover's algorithm to search all possible keys at once and find the right one much faster than a classical computer. Finally, imagine that you encounter a challenge where you have to solve multiple problems simultaneously. In a classical computer, you would have to solve each problem one by one, which would take a lot of time.
The future of quantum computing is bright, as the field is rapidly advancing and holds great promise for solving some of the world's most challenging problems. One area where quantum computing could have a significant impact is in cryptography. Quantum computers can potentially break many of the encryption algorithms that currently protect our sensitive data, but they can also enable new forms of secure communication and data protection. Another area where quantum computing could make a difference is in optimization problems. Quantum computers can potentially solve certain optimization problems much faster than classical computers, which could lead to breakthroughs in fields such as logistics, finance, and manufacturing. Quantum computing also has the potential to advance the field of materials science. Quantum simulations can help researchers better understand the behavior of molecules and materials, which could lead to the discovery of new drugs, materials with novel properties.